The earth pressure balance shield represents the ideal tunneling machine for homogeneous cohesive soil types, including those under the groundwater level, as the excavated ground is transportable and landfillable without any further treatment. Use of the earth pressure balance shield with segmental lining for tunnel cross-sections of 2 to 4 meters is therefore a particularly feasible and inexpensive solution for installing pipelines underground in long tunneling routes involving tight curves. The following animation graphics present the advantages of this application. A launch shaft is set up on the site. This can be achieved by means of sheet pile walls, slurry walls, or bore piles. Push rails for the machine are installed on the shaft bottom and the startup seal mounted at the front. The tunnel boring machine is delivered in modules and installed in the launch shaft. A temporary steel thrust bearing is mounted behind the machine. The TBM backup system initially stays above ground and is connected to the tunneling machine by connecting lines. The first 2 segment rings are mounted inside the rear machine jacket, the tail skin. Tunneling commences once the TBM has been fully connected to the backup system, with the machine tunneling through the lean mixed concrete block in front of the startup shield. After the first stroke, the thrust cylinders are retracted and the next segment ring installed under the protection of the tail skin. This is followed by additional strokes until the TBM is fully tunneled into the soil and there's sufficient space for the gantries. Finally, the thrust bearing in the shaft is removed and tracks are installed for the supply train, which comprises 2 wagons for transporting the segments, a mortar wagon, a supply wagon, and several muck skips for the excavated material. The segments for tunnel lining are supplied to the site by trucks, and depending on the available space, a store is set up right next to the launch shaft. The main crane serves to continuously supply the machine with segments and auxiliary materials, as well as to change the muck skips. A mortar mixing plant at the surface produces the required injection material for filling the gap between the segments and the soil. Regular tunneling is undertaken once the machine is fully launched, the gantries installed in the tunnel, and the assembly work inside the shaft is completed. The thrust cylinders are supported at the last segment ring built, and thus continue to press the cutter head into the ground. The force of the thrust cylinders is transferred to the rotating cutting wheel, while the cutting tools on the cutting wheel remove the soil from the tunnel face during tunneling. Openings in the cutting wheel transport the soil into the excavation chamber, which is completely filled with soil to securely support the tunnel face. If necessary, the consistency of the soil can be modified with foam to produce an ideal paste-like soil. The opening for the new screw conveyor, which discharges the material that follows, is in the invert of the excavation chamber. Operation of the machine is such that the earth and water pressure on the tunnel face and counter pressure of the ground in the chamber are balanced. Adjustment of the advancing speed and conveying rate of the screw conveyor makes it possible to control the balance of forces. As a result, there's no variation in the earth pressure, and the support required at the tunnel face is generated. Earth pressure sensors in the excavation chamber continuously monitor this balance, which is also controlled by the machine operator. All of the tunneling parameters are visualized at the control monitor. The excavated material is transported from the screw conveyor onto a conveyor belt. This conveyor belt moves the material to the end of the gantries. Muck skips are positioned under the drop point, where the material is transferred into the skips. After completion of the stroke, the machine operator stops the cutting wheel and screw conveyor. The supply train delivers the segments, material, and equipment needed for the next ring lining. The segments are lowered onto the segment lifter, and the train positions the muck skips under the conveyor belt's drop point. Once they've been deposited, the transfer crane brings the segments to the erector. The transfer crane and erector use vacuum lifters or a mechanical gripping system to lift the segments. The erector positions the segments one after the other on the flanks of the final ring. The hydraulic cylinders are pulled back briefly to create room for positioning the next segment. Following installation, the hydraulic cylinders are again extended to keep the lining segment in its position. The installation team bolts the segments to each other. The conical key segment completes the tunnel ring. The next stroke can now begin. The segments are fitted with circumferential seals. Once the segments are assembled in a ring, a dimensionally stable ring is created and fully sealed both circumferentially and against the previous ring.